Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam LTAM from the last fall 2019 exam LTAM. Problem number 7 in multiple choice section. An insurance company issues a special policy to a 65-year-old with the following benefits. A death benefit of $100,000 payable at the end of the year of death, provided death occurs before age 85, so during the first 20 years of the policy. A whole life annuity due of $45,000 per year starting at the policyholder's 85th birthday. You are also given annual level premiums of PIA payable for 20 years. Premiums are determined using the equivalence principle. Mortality follows the standard ultimate life table. Interest rate is 5%. And always pay attention. Note that whether the interest rate is consistent with the actuarial present values given in the standard ultimate life table. It is in this case 5% is the rate assumed in the standard ultimate life table. Pay attention to this. This is an easy trick to get you off track on the test, although it's not very commonly used, but occasionally they do ask questions where the interest rate is different than the one in the table. And you can use the size of the population, number of deaths, or the basic mortality data, but then you can't use you cannot use in such a situation the actual present values provided in the table. And your job is to calculate P, the annual level premium, which is payable for 20 years. And here's the solution. So if you ever want to find a standard ultimate life table, just go to smarturl.it/SULT. That's where the table is. Of course, that's not the URL set up by the Society of Actuaries. It's hidden somewhere in all the navigation of SOA. I just created this shortcut because it makes sense to know where things are. And I use the Smart URL forwarding service so that if you want to know of any website that matters, I have a smart URL for it. The expected present value at issue of death benefits is, well, it's 100,000 times a 65:20 with a 1 above the 65 because it's basically a 20-year term insurance. That's 100,000 times a 65:20 minus pure endowment 20E65. And the reason why we switched to this, because a 65:20 is an endowment policy, but if you take out its pure endowment component, then it's a 20-year term policy. That's why those two are equal. But the reason why we switched to these is because both these quantities, a 65:20 and 20E65, are given in the table, in SULT table, a standard ultimate life table, but I call it SULT. So whenever I write equals and SULT under it, that means you just look up the values in SULT, and we look them up, plug them in. So this is 100,000 times 0.43371 minus 0.24381, and that's equal to 18,990. The expected present value at issue of annuity benefits is 45,000 times 20E65 times A.85, because it's a life annuity deferred by 20 years with a payment starting at age 85, life annuity due all is good because now all of these quantities are given in the table. So this is 45,000 times 0.24381 times 6.7993, and that's 74,598. The expected present value at issue of premiums is P A double dot 65 colon angle 20, because the premiums are only paid over 20 years. And from the table, this is equal to 11.8920p. The policy is priced based on the equivalence principle, so the actuarial present value of benefits, the left-hand side of what you see here, 18,990 plus 74,598, so the total actuarial present value of benefits, both death benefits and annuity benefits, is equal to the actuarial present value of the premiums, which is 11.8920p. Of course, this actuarial present value is calculated at time 0 when the policy starts. So that from this is a simple linear equation in P. P is equal to 18,990 plus 74,598 divided by 11.8920, and that's approximately 7,869.83, and that's answer B. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.